Good morning, everybody. Thanks for coming to the first summit around Visor. It's been great to see many known faces and many new faces and lots of people that have been contributing and jumping into this community lately. And today, essentially, we are going to meet here to discuss some of the topics that are of interest.
Please mute.
While preparing this event, basically, Deborah, Wendy, Deepa, Brendan have been putting a lot of hours to basically make sure that all the logistics of the organization was going right. And of course, they asked Alexei and I if we could do some introduction. We didn't talk until this morning, obviously. Of course, until yesterday night, we didn't have anything prepared. I didn't have anything prepared, he neither. So we said, okay, fine, I'll put something because I know that he's not going to do it. So let's go a little bit through what was behind the ideas that we had when we started the Visor community, right? And the idea was that we were coming from networking backgrounds, especially kind of higher level features like load balancers, firewalls, intrusion prevention, and of course switching and routing. And the idea was that it was very painful that every time we should have to rebuild the whole infrastructure. We started with generic CPUs, then we went back to ASICs and FPGAs, then we went back to network processors. And through the whole process, there was a lot of wasted cycles on redoing again and again the same infrastructure. So when we started thinking about this project around 2010 and we started seriously in 2011, there was a lot of hype going on in terms of transforming the networking industry because everybody was aware that that was an unsustainable problem, that we had to rebuild things again and again. And a lot of times in proprietary ways, like a lot of ASIC vendors, a lot of networking vendors, that they would create their own protocols, their own encapsulations, their own APIs. And somehow, we were living in the right side of the slide where we had data planes for very specific functions exposed through southbound APIs, talking to controllers, some closed source, some open source, talking to northbound APIs and a bunch of applications on top. But the whole thinking was like, well, is this it? Is this redoing the infrastructure that we've been doing for the last 20, 30 years in a more open way the way to go? Or should we start thinking about how to create kind of a platform, an extensible platform that allows people to develop new capabilities. And in that, we always, as infrastructure people, we were always limited by our capability to start by the data plane. And if you think when you have companies like Broadcom, Marvell, Intel, and now a bunch of new generation like Barefoot and Xpline and so on, it takes 2 years to develop something. So programmability had to come into the data plane. And this was the beginning of the discussions about Visor. How to, rather than abstract a data plane by an API on some existing capability, how to expose a programmable interface, how to create a language, how to put it with a compiler. And this was kind of the beginning of the discussion. Of course, from a playground point of view, that was not the ultimate goal. That was not the only element that we had in mind, in the sense that when you start putting multiple data plane functions together is how do you combine them? How do you make sure that they coexist? How do you publish them? How do you have a repository in the internet? And this is some of the areas that this community has been trying to address lately. But the goal was how to move not only from data plane to data plane, from fixed function to programmable data plane, but rather how to give a platform where people can develop new capabilities. And this has been a long journey, but originally we started with kind of this kind of interesting name, where we were calling this programmable data plane a plum engine. And this was standing for the fact that basically the CPU people, the programming people had basically fetch the code, execute, store, and that was the pipeline of a CPU. So we had the idea of creating a pipeline for I/O, and this was the parse, lookup, update, and modify. And in 2011, we had this kind of dream that this in the future would be an abstraction that would cut across multiple data plane implementations. These are slides from our early days in January, February 2011, where we were saying, if we do this right, if we had a proper abstraction through compilers, why should we limit ourselves to a specific single implementation? And the idea was we should have software engines, we should have hardware engines, we should have ASICs engines, and more or less what we see after like 5, 6 years is that somehow the industry is going there. Of course, we had our crazy ideas on how the software would look like, and hopefully looks much better than what we were thinking, because otherwise we will have some problems. But that led to essentially the Linux community around eBPF and now the Visor project by the Linux Foundation. And I think the whole success of the community was this notion of embedding it within the Linux kernel. And the idea was that you can always focus on hardware later, but the first is how do you put it in a software engine that everybody has access to. If you think Linux was great because everybody had access to a Linux machine, versus if you start focusing on specific needs, specific hardware, or specific performance, then you limit a lot the community that can access to that. But at the same time, we're talking about networking, or we are talking about storage or other things. So there has to be a path towards performance. And on purpose, we decided that the path was to start with programmability, because that would create essentially a community that can develop crazy ideas, and knowing that performance would automatically come, because the nature of the problem. We focus on infrastructure, performance becomes mandatory, and then you have things like hardware engines, DPDKs, things like that, and even more important, something like XDP, essentially is bringing performance natively in Linux kernel. The community so far has these members officially. As you know, we didn't try to make a regular community from the point of view of you have to have memberships and there's a voice and so on, but rather this is more to support the community, to give some name to the community. But in reality, from the beginning, we wanted to build it bottoms up, driven completely by engineers, no long-term vision, no strategic planning, but rather make it useful from the people that they are using it. And so far, I think based on all the use cases that I've seen that everybody is developing is pretty interesting. I mean, way beyond some of the networking use cases that in our previous company we were like developing, and now has been much more towards security, tracing analytics, all the way up to storage and some of the use cases that are being developed. So in this sense, great progress over these years. And if you think just from a historical thing, what happened in 1 year? This was a slide from the summary that we had to do to the Linux Foundation about the progress of the Visor community. If you think last year we were saying, well, we should focus on flexibility, that we had it, but at the same time we should focus about performance. And at that point, this was just like a PowerPoint presentation. And during the 2016, we saw the growth of the XDP concepts and how to bring the performance natively in the Linux community. That this, for a long time, was thought to be unthinkable, how to kind of embed this within the Linux kernel stack, and somehow made it in, because it was important for people to be able to develop fast. The other was the notion of like, how many people are looking at this project, how many people are contributing. And if you think in December 2015, there were like 15 people that had ever checked in code, at least in the Visor GitHub repository. Now, I checked yesterday, there were 78. And the number of stars went from 250 to more than 2,500. This within 1 year. So very exciting from a progress point of view. And then, of course, from a Linux kernel point of view, now there's so many patches and so many writings and people looking at the features that come in each release that essentially is embedding more and more capabilities within what eBPF can do. So definitely great progress within the last year. And of course, this was possible not because there's anybody behind driving it or planning it or whatever, but rather than everybody that is contributing and helping. The excitement of the people creating new things and organizing events, meetups, in forums, and this has been kind of bottoms up. Like nobody driving it, engineers and people liking what they do, contributing and explaining what they do. So that's been the great part of that community. So where do we take it from there? And the answer is, well, as I said, that it comes from whatever the community feels like, the engineers develop, the people that create useful tools take it. But if you see, there is kind of a natural progression where in one area, number one, essentially is about the capabilities. How do we embed it within the kernel? How do we embed it within a hardware sys? How do we make the platform more and more capable from a number of permutations that you support? Because the idea was to abstract all these things in a single kind of SDK. The second is like, what do you add in it? What hooks, what coprocessors, what kind of helpers do you put in a way that we have more and more rich capabilities? And you'll see that there's some talks about those, about the performance, about the capabilities in the kernel. But more dear to me is the upper two. The next one is like, what abstractions do we create? Because if we keep doing the things that only work in a specific vertical, then we have to redo it again for all the other ones. So the idea is, how do we create those tools that become kind of a usable tools to create innovation, and they work across multiple data plane technologies? And here I'm very curious about the talks that Brendan Gred, Brendan Blanco, and Fulvio are going to give about the future of VCC, about the future of the tools, LibIOV. which is essentially the foundation on how do you create those new capabilities. And more important is like 1, 2, and 3, they are useless if you don't build capabilities on top that people can use. And this community has been very technical, very bottoms up, understanding the kernels, understanding performance, understanding compilers. And lately, there's been a lot of new tools being created on top. But I think still the place where we are falling short is number 4, is what can I do with it? I'm not a developer, I'm not a kernel hacker. I want to take this, I want to use it. For the people that feel like that, it's still kind of hard. So there's some efforts of even the OBS folks, like trying to use it and create something usable. Fulvio, Steam has been doing something else. Then Brendan from the storage point of view and analytics. But the idea is like, as the community matures, how can we give tools and capabilities that we go up the stack in a way that everybody can find it useful? And this is kind of the place where I'm deeply interested and looking forward to see all your talks and all the areas of innovation and see where it goes next year. Alexei, anything else?
Excellent, excellent. Thank you so much. Only wanted to say a few words here. First and foremost, thank you everyone for supporting each other to make this community happen, for us to come together, to grow it, because 2 years ago, 3 years ago, whenever it was, long ago, yeah.
1 year and a half.
It was really nothing, and I think if not because like each and every one of you, we wouldn't be here today. So to me, it's the greatest achievement. Greatest achievement of all of us, and I'm really thankful for that. A few examples of that would be unthinkable before. Right now, the BCC tools and Brendan Gregg's tools, as they now know, they're already part of several distros, like Ubuntu and Fedora ship them. In Facebook, the BCC tools are installed on every server in a data center, and a large number of engineers already using them on a daily basis. So, and some of them, like without them, it reduces the time to like the debug time, like by the order of magnitude. So, like this is like huge progress. This was not possible before, and here we are today. So, thank you. And changing the gears, I think everyone has different expectations for this day. It may be a long day. People get tired, but what I want to see out of today's is for us to get together even more, to know each other like pain points, what we want to achieve, how we want to use something, how do we want to use the technology today, where we want to go with it, and pretty much meet each other and socialize. So, and hopefully to achieve that. So the way I'm looking at all the presentation that will happen is it's not a one-way information flow. We all need to interact. Otherwise, we will not be here today in one room. So to make it more interactive, let's do a quick introduction, because I think I know most of the faces, but not all of them. And I suspect some of the folks here. So just the name and the name of the company would do. So I will start. I'm Alexei from Facebook.
I'm Pere from VMware. I'm Brendan from VMware.
Alba from Kingfolk.
I'm Thomas. I just left Cisco doing a startup.
Marco from VMware. Fabio from VMware. Alexei from VMware. Riaz from Docker. Roy from Docker.
Jacob from National.
Nick from Netman. Nikos from Cisco Systems.
Kian from VMware.
Mihai from VMware.
William from VMware. Ben from VMware.
Joe from VMware.
Daniel, formerly Cisco.
Yamcha from Huawei.
Naga, sorry. Anja from Huawei. Yusuf from Huawei.
Nikita from Facebook. Tom Herbert from Facebook.
Deepa?
Deepa from VMware.
Justin from Docker.
Deirdre from Emerson.
Brendan from Netflix.
And John from Info.
Excellent. Thank you, guys. That's all I had.
So who's next? I think Brendan.